Good morning children. Now I am going to explain grade 10 mathematics chapter 2 polynomials. Introduction of polynomials and the types of polynomials and their zeros and their geometrical meanings. First of all, polynomial. What is a polynomial? An algebraic expression with non-negative integral powers is called a polynomial. An expression which have only positive integers as its exponents or powers is called a polynomial. And then degree of a polynomial. The highest power of all the variables involved in the expression is called the degree of the polynomial. The highest power of the variable is called the degree of the polynomial. Based on the degree, polynomials are classified. Linear polynomial. A linear polynomial means a polynomial of degree 1 is called a linear polynomial. Polynomial of degree 1. For example, 2x minus 3, root 3x plus 5. Here all the variables are having 1 as its degree. So they are called as linear polynomials. Next, quadratic polynomial. A polynomial with degree 2 is called a quadratic polynomial. For example, 2x square plus 3x minus 2 by 5. Here the highest power of the variable x is 2. So that is why it is called as a quadratic polynomial. And then cubic polynomial. The polynomial of degree 3 is called a cubic polynomial. The general form of a quadratic polynomial is ax square plus bx plus c, where a, b, c are real numbers and a is not equal to 0. In the same way, the general form of a linear polynomial will be ax plus b, where a and b are real numbers and a is not equal to 0. And here the general form of a cubic polynomial, ax cube plus bx square plus cx plus d, where a, b, c, d are real numbers and a is not equal to 0. And then the value of a polynomial, value of polynomial. If p of x is a polynomial in x, then if k is any real number, then the value obtained by replacing k by x by k in p of x is called value of polynomial p of x at x is equal to k. Means by replacing the variable with any real number, the value obtained is called the value of a polynomial at that value, at that x is equal to something value which you have replaced. For example, take a polynomial p of x is equal to x square minus 3x minus 4. Now we are substituting x with minus 1 at x is equal to minus 1. How do you get that? By replacing x with minus 1, and it is denoted by what? P of minus 1. Instead of x we are writing minus 1. So it is denoted by P of minus 1. P of minus 1 is equal to minus 1 whole square minus 3 into minus 1 minus 4. The value is 0. And if you replace with 4, then x is equal to 4. We are substituting x is equal to 4. Then p of x will become p of 4. P of 4 is equal to also, here we got 0. Okay, this is called the value of a polynomial. Replacing the value obtained by replacing the variable by a real number is called value of that polynomial at that real number. Next, zero of a polynomial. Zero of a polynomial. See, zero of a polynomial means for which value of the real number the polynomial becomes 0, then that value is called the zero of a polynomial. To which value it becomes 0. See, if you observe, p of minus 1 is equal to 0 here and p of 4 is equal to 0. For the values of, at the values of p of minus 1 and plus 4, the value of the polynomial became 0. That is why p of minus 1 and 4 are called zeros of the polynomial. See, a real number k is said to be 0 of a polynomial p of x if p of k is equal to 0. To which real number the value of the polynomial becomes 0, then that real number is called 0 of that given polynomial. This is about zeros of the polynomial. And then see here, how do you find the 0? 0 is nothing but a solution or root. What is meant by solution of an expression or equation? The value of the variable is only no solution. See how to find the solution of a linear equation, linear polynomial. If p of x is equal to ax plus b, it is a linear polynomial. Then if k is 0, if k is 0 of a polynomial means for the value of k, the polynomial became 0. So what can you write? P of k is equal to 0. See here, minus 1 is 0 of a polynomial p of x. Then what is the result? P of minus 1 is equal to 0. In the same way, here P of k is equal to 0. P of k means replacing x with k. Ak plus b is equal to 0. Then k is equal to minus b by a is the 0 of the linear polynomial. What is the relation here? Minus b means minus of constant term by a means the coefficient of x term. So, what is the relation between 0 of a linear polynomial and its coefficient? 0 of a linear polynomial minus b by a is equal to minus of constant term by the coefficient of x term. This is about the 0 of a linear polynomial. And then geometrical meaning of the zeros of a polynomial. What is the relation between the 0 of a polynomial and its geometrical meaning means and its graph? If you draw a graph for a linear polynomial or quadratic or cubic polynomial, what is the relation between that graph and the zeros of a polynomial? Now we are going to see that. The relation between zeros of a polynomial and the graph of that polynomial. First of all, consider a linear polynomial. Y is equal to 2x plus 3. If you find 0 of that polynomial, what will be the value of x? X is equal to minus 3 by 2. 2x plus 3 is equal to 0, x is equal to minus 3 by 2. So, what is the solution for this 2x plus 3? X is equal to minus 3 by 2 is the solution. Keep it aside and let us see the graph. How to draw graph for a linear polynomial? Here we have a polynomial y is equal to 2x plus 3. We have to substitute x with some real numbers and we should get the corresponding y value. If you consider x is equal to minus 2, then what will be the value of y? Y is equal to 2 into x plus 3, no? So, 2 into minus 2, minus 4 plus 3, that is minus 1. If x is equal to minus 2, y is equal to minus 1. In the same way, if x is equal to 2, y is equal to 7. So, here we got 2 points. Minus 2 minus 1 is 1 point and 2 and 7 is another point. Plot these 2 points on the graph and join those points. Join those 2 points. Then we have obtained a straight line. In grade 9 also we have learned the graph of a linear polynomial is a straight line. So, we got a straight line, no? Now, observe where this straight line is intersecting with x-axis. See, this straight line is intersecting with x-axis at this point. What are the coordinates of this point? As it is lying on the x-axis, y coordinate will be 0. Let us see the x coordinate. Where it is intersecting? It is intersecting in between minus 1 and minus 2, exactly at the midpoint of minus 1 and minus 2. That is what? Minus 1, 1 by 2. Minus 1, 1 by 2 means it is minus 3 by 2. Minus 3 by 2 and 0. So, the graph of the linear equation, the straight line, is intersecting the x-axis at this point minus 3 by 2 and 0. Now see, the x coordinate minus 3 by 2 is equal to the solution of this linear equation. The solution of this linear equation is also minus 3 by 2 only, no? So, what can you say? The 0 of his linear equation is equal to the x coordinate of the point where the graph intersects with x-axis. So, this is the relation between the 0 of a linear equation and the graph of the linear equation in one variable. Next, coming to the relation between the zeros of a quadratic equation and its graph. Let us take a quadratic equation. Y is equal to x square minus 3x minus 4. If you solve that quadratic equation by splitting the middle terms, we will get the roots as minus 1 and 4. So, the zeros of a quadratic equation, the taken quadratic equation are minus 1 and 4. Now, let us check the relation between these zeros and the graph. So to draw the graph of a quadratic equation, we have to consider some values for x and find out the corresponding values of y. Then we will get these points and plot all these points on the graph. If you join all the points, you will get this shape, and it is called as a parabola. It is a parabola. So sometimes you will get a parabola which is at upwards, and which sometimes you will get which will be downwards. So if the x square coefficient a is more than 0, then the parabola will be in upward direction, and if the x square coefficient a is less than 0, then the parabola will be in downward direction. Okay, so now let us see the points where this graph has intersected with x-axis. See, at how many points this graph has intersected with x-axis? At 2 points. What are those 2 points? See, this is 1 point and it is the another point. So let us see the x coordinates of these points. As these 2 points are lying on x-axis, the y coordinates will be 0. And looking at the x coordinates, see, it is intersecting at -1. So the point will be -1 and 0. The x coordinate is -1. And the second point is 4 and 0. Here the x coordinate is 4 and 4. So let us see what are the zeros of this quadratic polynomial which we have taken. They are -1 and 4. They are equal to the x coordinates of the point where the graph intersects with x-axis. So here also same like linear polynomial only. The zeros of a quadratic polynomial are equal to the x coordinates of the points where the graph intersects with x-axis. So this is the relation in quadratic polynomials. So in quadratic polynomials, graph may be in these cases, in these 3 cases. See here, if the quadratic polynomial has 2 roots, graph will intersect the x-axis at 2 points. So if here it is downwards parabola. So here ai, the x square coefficient a is less than 0. Here it is upward, so the x square coefficient a is more than 0. In some quadratic equations, they will have only one solution, 2 equal solutions, that is considered as 1. So the graph will intersect only at 1 point. So see here in these 2 graphs, it has intersected only at 1 point. What does it mean? That quadratic equation has 2 equal solutions. So only the same root it will have, same 0 it will have. So it intersects at only 1 point. And some of the quadratic equations will not have real zeros. Then the graph will not intersect at any point. So you can see the relation between the number of zeros and number of intersecting points also. Here, as there are 2 zeros, the graph has intersected at 2 points with x-axis. Here, as there is only 1 0, it has intersected only at 1 point with x-axis. And in this third case, there are no zeros for that quadratic polynomial. That is why the graph did not intersect with x-axis. Understood, children? So, in quadratic polynomials also, the relation between the zeros and geometrical meaning is the zeros of a quadratic polynomial is equal to the x coordinates of the points where the graph intersects with x-axis. Coming to cubic polynomial, the maximum number of zeros for a cubic polynomial are 3. It can have either no zeros or 1 0 or 2 0 or 3 zeros. So let us consider a cubic polynomial x cube minus 4x. So if you find out the solutions of zeros of this cubic polynomial, x is equal to 0, plus 2 and minus 2 you will get. So the zeros of a cubic polynomial are minus 2, 0 and plus 2. Because see here, x square minus 4x, now take x as common, then it will become x minus 4. X minus 4 can be x cube minus 4x. So x square minus 2 square you can write. Then it is x plus 2 into x minus 2. Then what are the zeros? 0 is 1 0, plus 2 is 1 0 and minus 2 is another 0. So we got 3 zeros for this cubic polynomial here. Let us see the graph also. So by taking some values of x and getting the corresponding values of y. If you plot the points on a graph, see the graph of a cubic polynomial will be like this. See at how many points that graph has intersected with x-axis. It has intersected at 3 points, 1, 2 and 3. Look at the x-coordinates of all these 3 points, -2, 0 and here +2. So here also the x-coordinates of the points where it intersects with x-axis are equal to the solutions of this cubic polynomial, zeros of this cubic polynomial. And if a cubic polynomial has only one root, the graph intersects with x-axis only at one point. If it has two roots, for example, if you take x cube minus x square, it have two roots. 0 is one root and +1 is one root. So that is why the graph has intersected at 2 points, at 0, 0 and 1, 0. Here also the number of zeros is equal to the number of intersecting points, and the zeros are equal to the x-coordinates of the intersecting points, x-coordinates of the point where the graph intersects with x-axis. So that is the relation. See here, so by seeing all these results, we can conclude that a polynomial p of x of degree n, then the graph y is equal to p of x intersects the x-axis at most n points. So see here, the linear polynomial has intersected at only at one point. Quadratic polynomial has intersected either at no points, either it did not intersect, or it has intersected at one point, or it has intersected at 2 points. So as the quadratic polynomial have at most two distinct zeros, so the graph will intersect at most 2 points. In the same way, cubic polynomial at most it will be having 3 zeros, so the graph also intersects at most at 3 points. In the same way, the polynomial with degree n intersects the graph at most at n distinct points, and it will have at most n zeros also. So this is about the zeros of the polynomial. See in this example, by saying the number of intersecting points, you have to say how many zeros does that polynomial has. See here, the graph has intersected at one point with x-axis. So this polynomial will have only 1 zeros. And here at second graph 2, it has intersected at 2 points. So this polynomial will have 2 zeros. Here it has intersected at 3 points. So it will have 3 zeros. So based on the number of intersecting points, you can be able to tell the number of zeros of the given polynomial. And the exercise 2.1 is about that only. And then we are going to see the relation between the zeros and coefficients of a polynomial. See, if you take previously we have proved the relation between the zero of a linear polynomial is equal to what? 0 of a linear polynomial x is equal to minus b by a. That is what? Constant term by coefficient of x. See here we have proved no? Constant term by the coefficient of x. The 0 of a linear polynomial minus b by a is equal to minus of constant term by the coefficient of x. This is the relation here between 0 and the coefficients of the linear polynomial. In the same way, coming to quadratic polynomial, let us see the relation here. So to prove that, let us take one quadratic polynomial. Take a quadratic polynomial and find out the roots, zeros. See, 2x square minus 8x plus 6 is a quadratic polynomial. So by solving that polynomial by using splitting the middle term, see here, by splitting the middle terms, if you solve, you will get the solutions as 1 and 3. X is equal to 1 is 1 0 and x is equal to 3 is another 0. Now let us see the relation. Sum of zeros. Add those two zeros. 1 plus 3 is equal to 4. This 4, how this 4 is related with the coefficients of that quadratic polynomial? Can we write 4 as minus of minus 8 by 2? Minus of minus 8 by 2 is plus 8 by 2, that is 4. So minus of, what is minus 8 here? X coefficient by, what is 2 here? X square coefficient. So the sum of the zeros of a quadratic polynomial is equal to minus of x coefficient by x square coefficient. And product of zeros 1 into 3 is equal to 3. This 3 can be written as 6 by 2. 6 by 2. How it is related with the coefficients? Constant term by x square coefficient. Constant term is 6 and the x square coefficient is 2. 6 by 2 is equal to 3. So, in a quadratic equation, the sum of zeros is equal to minus of x coefficient by x square coefficient, that is minus b by a, alpha plus beta. We will denote those zeros with alpha and beta. Alpha and beta are Greek letters and we will pronounce them as alpha and beta. So, sum of the roots alpha plus beta is equal to minus b by a. Minus b means what here? X coefficient by a is x square coefficient. And alpha beta is equal to c by a, constant term by x square coefficient. So, this is the relation between the sum of the zeros and the product of the zeros in a quadratic equation and its coefficients. And then by using if he gives sum of the zeros and product of zeros, how to find out the quadratic equation? To find the quadratic equation, so x square is minus of alpha plus beta into x plus alpha into beta. See here, this is the formula. X square minus alpha plus beta into x plus alpha into beta. Sometimes it will have the coefficient also, constant term will be there. So, k, that constant is taken as k here. So, kx square minus k into alpha plus beta into x plus alpha into beta. So, if sum of the roots and product of the roots are given, we can find the quadratic equation by using this formula, x square minus sum of the roots into x plus product of the roots. Thank you, children.